In the last year, we've seen numerous studies reporting on the wide range of security incidents that have plagued Kubernetes applications. For example, a report recently found that half of the images available on the Docker repository contains at least one critical vulnerability, and the report was based on a sample size of more than 4 million images. We saw a stream of exploitable flaws found within Kubernetes services and its popular utilities, and many instances of misconfigurations, coding errors, and bad security practices that caused major security incidents throughout the entire year. Last year also saw a 430% increase in the growth of next-generation cyber attacks found inside popular open-source software projects. And there have been multiple alarming reports of sophisticated hacking teams, both criminal and nation-state, actively seeding open-source projects with malicious logic and using software update services as dynamic backdoors to insert malicious code at runtime. In fact, I wrote a blog that highlighted reports capturing the top 2021 new exploits, attack patterns, supply chain attacks, and criminal business strategies that targeted public and privately hosted Kubernetes deployments. And it's really all of these concerns that have been driving the interest for DevOps teams to explore how to integrate least permissive security policies into their projects. Least Permissive Application Management is really about designing your applications with the assumption that they are being deployed in a hostile cyber ecosystem, where no layer of your Kubernetes stack should be assumed trustworthy, and you need to manage your apps with the presumption that the security breach has already occurred. This includes structuring services to remove all trust assumptions between your workloads, surrounding each workload with the least permissive permission model, and monitoring violations of those permissions at runtime. And it's here where AccuKnox is developing open source security services that allow DevOps teams to apply these principles in an efficient and agile manner. Let me explain how we integrate runtime protection into your pods and how it works to secure your workloads while they are running. Once you've selected a pod that you want to secure, you can begin by installing a runtime protection agent on a host that has a copy of your pod. Our package is called KubeArmor. KubeArmor hooks into the host kernel and does a fine-grained analysis of the system calls and arguments that are made while the pod is running. This analysis produces a smart permission model that captures all of the security-relevant actions that your pod needs to use. The policies are implemented in YAML, along with tools that let you inspect and tune these policies to capture exactly how your pod should be constrained when it runs. We can now run the pod as before, only this time we have a runtime monitoring and enforcement engine that knows what the pod should and should not be allowed to do. KubeArmor essentially configures the pod-specific YAML security policies into the operating system's native kernel security services. It deploys the security policies using the kernel's loadable security modules, or LSMs, which enables it to restrict the pod's runtime behavior down to its least permissive constraints. It also uses the native eBPF service to add pod and name-specific metadata to its audit records and alerts, so you can identify the exact pod, container, and specific app responsible for each event or policy violation. What's cool about KubeArmor is now we have an ability to perform selective, fine-grained system call level auditing inside the pod, receive reports when policy violations are detected, and even activate inline policy enforcement for preventing critical security policies from being violated. KubeArmor lets you deploy fine-grained app-level security policies per pod, applying app-level constraints on all communication interfaces, file system and resource accesses, process management, administrative operations, and more. And don't forget, each baseline security policy spec can be auto-generated by KubeArmor. Never trust an app if you don't have to. Stay safe, and if you're a Kubernetes developer or admin, please feel free to check out our open source security projects. By the way, if you visit our blog, we have a continuous stream of posts that explain how our runtime security services block the latest attacks, hacker teams, 0 days, and malware that plague Kubernetes development teams.